Good morning to one and all. Today we'll see Unit 5, coping with the limitations of algorithm power. The first topic of Unit 5 is backtracking. So now we will see the fundamentals, introduction about the backtracking. Yeah, this is the history of backtracking. Backtrack, the word first coined by Dr. D.H. Lehmer in 1950s. Then R.J. Walker, the first man who designed the backtracking algorithm in 1960s. Later developed by S. Coulomb and L. Baumet. Now what is backtracking? Backtracking is a modified version of brute force approach. Already we know what is brute force approach. So brute force approach is nothing but continuously guessing the possible solutions until you find the correct solution. For example, if you forget the password of your mobile, you are giving the various possibilities of the password to find the correct password. So this is brute force approach. So backtracking is modified version of brute force approach, where the technique systematically searches for a solution to a problem among all available options. It does so by assuming the solutions are represented by vectors. So all the solutions are represented by vectors. This approach systematically searches for a solution to a problem among all available vectors. Okay, this is the definition for backtracking. It's very important. Next, the algorithmic approach. What is backtracking algorithm? So already we know backtracking is a systematically search possibilities to find the solution. Also, it is an important process for solving constraint satisfaction problem like crossword puzzle, Sudoku, and many other puzzles, and also for n queen. These are the various problem we can apply backtracking approach. Basically, the process is used to when the problem has a number of options and just one solution have to be selected. After a few options, set means recursion. So the procedure is repeated over and over until the final solution we find. So this is backtracking algorithmic approach. This is the pseudocode or algorithm for backtracking. So already I said backtracking is the finding solution among the available vectors. So here backtrack V1 to Vi. Okay, if V1 to Vi is the solution, then return V1 to Vi. This is various possible solutions, that is vectors, various vectors. I may be n, 1 to n. For each vector do, if Vi to Vi, V1 to Vi is acceptable vector, then solution is try the solution. If solution is not available, then return solution. Further not available, then return the solution. So backtracking, when we see an example, you can understand easily the backtracking algorithm. Advantage of backtracking is comparison with the dynamic programming. Backtracking approach is more effective. Then backtracking algorithm is best option for solving tactical problem. Also backtracking is effective for constraint satisfaction problem. And in greedy algorithm, getting the global optimum solution is long procedure and depends on user statements. But in backtracking, it can be easily possible to get the global optimum solution within a short procedure. And backtracking technique is simple to implement and easy to code. Also, different states are stored in a stack so that the data or information can be usable anytime. The accuracy of backtracking is guaranteed. Disadvantages of backtracking algorithm is it is not sufficient for some solving strategic problem. The overall running time of backtracking algorithm is very slow. To solve large problems, sometimes it needs to take the help of other technique like branch and bound technique and some other techniques. Then it needs larger amount of memory space for storing different state function. So we have a different solution, sub-solutions. So you need a memory space to store the different state functions in the stack for a big problem. Thrashing is one of the main problem in backtracking. The basic approach detects the conflicts too late. These are some major disadvantages of backtracking algorithm. Then various applications of backtracking algorithm is optimization and tactical problem, constraint satisfaction problem, electrical engineering problem, then robotics, artificial intelligence, genetic and bioinformatic algorithm, material engineering, network communication, solving puzzles and path. So these areas we can apply backtracking technique. And some of the problems solved with backtracking technique is n-queen problem, sum of subset, Sudoku puzzle, maze generation, Hamilton cycle. These are some problem we can solve with the help of backtracking technique. That's all about the backtracking technique. This is the fun introduction of backtracking technique. Just recall the information what we learned today. So first, backtracking, the history of backtracking from 1952 till date. It is emerged at 1950 and slowly the algorithm is found in 1960 and later developed by S. Coulomb and L. Baumet. Definition for backtracking is nothing but modified version of brute force approach. It is a technique systematically searches for a solution to a problem among all available options. Then backtracking approach is systematically try and search possibilities to find the solution. Also it is an important process for solving constraint satisfaction problem like crossword puzzle, Sudoku puzzle and other puzzles. Then algorithm we have seen. Then advantages, there are many advantages. Backtracking approach is more efficient. It is a best option for solving tactical problem. Also backtracking is effective for constraint satisfaction problem. It is easy to implement and it is storing the result, sub result or sub solutions. We can reuse this result at any time. Accuracy is granted. All these are advantages and disadvantages. It is not sufficient for some problems and overall running time is very slow. Then to solve a larger problem is very difficult because it needs some other techniques like branch and bound, etc. Then thrashing is one of the major big problem. So like there are some advantages there in backtracking and applications, constraint satisfaction problem, robotics, AI, genetic engineering, material engineering, network communication, solving puzzles. These areas we can apply backtracking. And the problem which is solved by backtracking is n-queen, then sum of subset, Sudoku puzzle, maze generation and Hamilton cycle. Thank you. That's all about the backtracking technique. We'll see in the next class with one example for backtracking technique. I hope we can see a n-queen problem for next class. Thank you. Thank you one and all.